So our last talk for today is called 99 Problems by Vyrus. Enjoy.
Okay, so this talk is, for my job, I'm a red team operator / penetration tester, so I do a lot of breaking into things. But the way that I get paid to break into things is usually a little different than your standard pen test. Your standard engagement is going to be, looking for vulnerabilities or analyzing software and looking for flaws and things like that. And a lot of the stuff that I get paid to do is basically simulated espionage. So it's a lot less running Nessus and a lot more fishing my way into a power company and staying in a network for 2 months and trying to figure out how to turn something off or how to make financial decisions as the CEO because I can figure out weaknesses within his family. Like I know where his daughter goes to school. I know that his wife is cheating. Like these kind of things. These are to get to that ability. So it's very similar to the things that actual spy actors do. And as such, the software has to be the same. And I've got to roll my own. And since I'm not the NSA with a room full of people that I can pay to do my bidding, I have to write my own. So this talk is basically about just the technical flaws involved in writing that software and how a lot of it, especially when you try to make it multi-platform or more widespread or actually use it to perform intelligence gathering tasks as opposed to, ooh, looky, I got a shell, is actually demonstrably more difficult and more involved than just leveraging an exploit. So disclaimer, we're talking about technical techniques here. We're not talking about the moral implication of using them. You are responsible for what you do, not me. I'm just talking about tech, right? If you choose to use it to do something shady, that is not my fault. I'm going to point at you and laugh. So rule number 1, the job of spyware is to spy. There seems to be this disconnect in like the informal hacking community that gets really excited about, ooh, I got a shell. All right, great. Like shells are fun, but shells are ways to do things. They're methods of influence, methods of gathering information. Like I used to work with a guy, Chris Gates. He had a famous saying: "Root is only the beginning." Right. So the goal is simple in terms of any of this activity, any of this kind of espionage type of stuff. Get as much data as you possibly can without being caught, because pretty much. As soon as your target knows that you're listening, your op is basically blown. And there are lots of pitfalls to that. So first of all, memory corruption really, really makes things inconsistent. So all these fancy bugs that we hear about coming out of like spy agencies and stage fright and Heartbleed and all these crazy stuff. Yeah, that stuff's great and fun to use at home and to mess around and tie a bunch of exotic things together. And if you actually have an army of people who can tailor your implant to exactly the target that you want, then awesome. But most of us don't have that. We're maybe like 1 to 3 people, depending on how big your hacker crew is. And things like memory corruption are frankly dangerous because usually they break in the wild. It's always safer to just log in and use a password. Disk writes are to be avoided at all costs because that's how AV and everything else that catches you works. They all look for writes to disk, so avoid them if possible. Anything that triggers an event, so if you're going after a large organization, things like loggers or syscall dumps, if they have external event systems, if they have backups, and sometimes the backups are hashed, and if the hash changes, that'll trigger an event. Anything that alerts a monitoring party that a change has happened is something to be avoided. This also includes things like network volume and CPU load. If your phone suddenly starts eating all the battery, you notice, right? If suddenly, I mean, how many people have, everybody in this room, I'm assuming, has used a torrent before, right? Well, all of you know when you stop downloading and you start seeding, right? Because you're on Netflix and you're like, fuck, it doesn't work. And then you go, oh yeah, I was downloading that thing, yeah. Visible changes to the UI, obviously don't hide malware on the desktop. For the most part, I have done it and watch it work. People are silly. Reverse engineering is an ever-present threat. Anything you do online, somebody somewhere at some point in time is going to find it, and they're going to reverse it if it's any good. If they don't reverse it, it's probably because it was boring, right? And this isn't just digital systems, this is in general. Like everything we know about spying, we know because on a long enough timeline, the survival rate of anything goes to 0, and that includes intelligence tactics, right? I mean, if you really want to know about what your spy agency next door is doing to you right now, go read a history book. Guarantee you they're using the same tactics, it's only slightly different technology. So TLDR, once your target suspects your existence, you lose. Your op is blown. At that point, they're looking for you, and you're playing a very different game of cat and mouse. So, like I said, rule number 1, steal as many things as you can. More data is always better. Whatever your goal is from your simulated espionage or, insert plausible deniability message here, you're doing science, right? I mean, you're doing data categorization, you're doing association, you're doing analysis. These are all forms of science. Science needs data. The more data you have, the more science you can do. Very simple. That being said, data science is hard. It's hard to figure out if, I'm trying to think of a plausible example. If you want to, let's say, get physical access to a company, any company, well, the first thing that it's probably easier to do is to figure out, before you figure out how to blend in or badging access or any of that, you want to know, for example, what entrance do they use? Well, that's probably marked in an employee manual somewhere, and that means you have to get it. So you may be stuck going through a company wiki, depending on the size of the company, that is terabytes of data, and some of it's old, some of it's been overwritten, some of it's incomplete, and they're human, so they all know, oh yeah, we don't use that one, we use this other one, or that's old, we use this other data, or this is the documented version that you need to go look up, and this is the way that we trade it. Doing that type of analysis is hard, and you, as a person without a team of people to do that analysis, it's very important that when building your tooling, that you tool towards that, because it's going to be very difficult. Automation is king, and hacker tools do not automate. Like the thing that led me down the path to writing some of the stuff that led to this talk is entirely because of the failure of other tools under scale. How many in here have ever used Metasploit before? All right, what's the maximum number of shells you've ever sent through Metasploit at one time? More than 5? Anybody? More than 10? More than 100? Yeah. Depending on, the most I've ever gotten through a single instance is somewhere around 300, and that was on a machine with almost a terabyte of RAM. And I got to maybe like the bottom 10% of that for about 20 minutes, and then the whole thing shot to bed. Tooling is hard. Taking that to its logical conclusion, scale is hard. Running 200 shells through a single Meterpreter instance is one thing. Having a database that can hold all the data is another. Having a load balancer that doesn't crap out or doesn't advertise your presence. Being able to move through burnable IP addresses without sacrificing your volume. These are all things you have to think about in terms of scale. And unlike a classical, Docker wielding web app admin, when your IP gets caught, you have to pick up and move it. You can't just stick stuff in front of it. You can't just go pay more money and buy more space. You basically have to do all the work of a typical DevOps engineer and all the mobility of a technical spycrafter as one person. Multi-platform is required, so required, because I guarantee you in the wild, yeah, I know, right? I like that slide. I'm very politically incorrect, in case that wasn't clear. Fuck your safe space. I teach. You don't like it, leave. Yeah, multi-platform is a thing because Metasploit's a great example. Yeah, Metasploit works great until you get a shell on a security camera and it runs in MIPS. Oh, fucking well. Yeah, definitely something to keep in mind. You are a human. You have to use your own tools. If your tools are hard to use, you won't use them. This is important. If you get some crazy O-Day and it takes you 20 minutes of command line trying to fire it up, I guarantee you'll never use it because the opportunity to launch it is going to be faster. You're going to get an alert on something, you're going to get a successful fish, and it'll die once in the middle of you trying to deploy it. And I guarantee you, you're a human, you'll never use it again. And you shouldn't, because at that point it's not effective. Tools are a hybrid of capability and usability. It is important to remember the usability piece, and we're all nerds, so we have a tendency to forget that. Why did I put that image in there? Let me read my notes. If my thing will work. I remember why I put this in here. As part of your UI, centralization is going to be important. If you have 20 shells on 20 different IPs and you decide that you want to use all of them to go after a target that, let's say, is moving. I did a job once where the goal was, for lack of more explanation for obvious reasons, to compromise a system that was hooked to a network on a truck, and the truck was constantly moving around the country. So I had a bunch of shells on the grid systems that communicated to this truck as it went from place to place, but I didn't know where the truck was, and for lack of more explanation, predicting where the truck was going to be was more or less impossible. At one point, I got a shell on the truck. Now, how do I not lose the shell? I did it, but the way that I did it is I ended up having to tool a very centralized control mechanism for something that should have been very simple, and it took 3 days. So now the rest of this talk is mostly just going to talk about tactics for achieving all those things. At the end, I have a sample kind of spyware piece that I've been using on some recent engagements, and I have one engagement that's using it currently, and it's still under development. So I'm going to ask that the recording not record that portion, but I will show it to everyone in the room, at least in pieces. But the code will not be public for a while. I might drop it in a few months, but there's nothing really secret in it. It doesn't use any vulnerabilities or exploits or anything, and actually most of the code is frankly borrowed from Stack Overflow. It's just all cobbled together in a pretty little package and is cross-compilable. So the first method, like I said, you want to stay in as long as possible. You want to be as invisible as possible, and we don't want disk writes. So that means staying in memory. Persistence is key, and persistence without disk writes means in-memory persistence. So probably the best documented way to do that, for sans a lot of other explanation, is probably shared object injection. So there are a lot of ways to do shared object injection. On Linux, probably one of the more stable ways, although it is kind of loud if you've got things like sysinternals and GRU installed, is the ptrace method. So basically, you take a process and you pause that process, usually set debug, but you pause that process, and you use a function called ptrace, which is designed to manipulate callbacks to certain standard functions in Linux, usually for the purposes of debug, but you can use it for whatever you want. So one of the things you can do is you take the pointer, you find the exception function, the thing that is supposed to, oh my God, something broke, and it calls an exception. In ptrace, it has its own exception handler. What you can do is you can change that exception handler to your own function, and then you set EIP to 0, basically. You set the stack pointer to 0, which means as soon as you hit resume, you're going to force a null execution, which is going to cause a break, and then ptrace is going to execute. It's going to call your function, and then you pause it at the end of that, and you set your process back to the way that it was, and you continue. And so that function is where you hide your special sauce. Very similar, hooking syscalls. This works on every operating system, and I've got some other slides that have some details on how to do it. Basically, on Linux, the kernel is a giant blob of functionality, and everything else that works eventually boils down to that functionality, and that functionality is defined as a series of syscalls: write, read, execute, etc. Those syscalls are stored on a standard table, and basically you can pause a process, and then you can go in that process and find the system table and go, every time you call this syscall, don't call my function instead. You command in the middle of it. And beyond that, there's a bunch of other injection tactics that you can do inside ELFs, because ELFs are relatively poorly designed, but they're much better documented than PEs or OS X. We'll get to that later. But frankly, to do anything useful on Linux, you probably have to be root anyway. And if you're root, hide your stuff in the kernel. No one will look. Yeah, all of you claim, they're like, oh, thread security, and I'm the LS mod, and I can see it. And nobody does that shit. Nobody. You pop a web server, you hide a kernel module there. You can do none of the fancy making sure that things don't, list in an LS mod or modifying the LS binary to ignore your process. You don't have to do any of that stuff. I guarantee you, nobody looks. So on Windows, shared object injection is DLL injection. So the easiest ways to do this, these are great, right? So there's, this is the first one. This is a registry key called appinit DLL. Appinit DLL is a registry key that is by default blank. And if you set it to a place on the file system, every single time any program in the entire computer loads user32.dll, which is the Windows API, it will also load your DLL. Done. Persistence over. This is another registry call that will do exactly the same thing every time a user logs in. So then you get context-sensitive data, which is good because remember, steal everything. So context is key. It enables us to index. This is kind of the more traditional way. This is the way like Metasploit and all the other kind of available tools that are out there do it. You basically pause a process, you create a remote thread, and you create a thread, you put your shared object in your thread, and you point to it, and you resume the process. And there's like a 4-stack thing, but it's super well documented. I'm not going to get into it. You can totally Google it. This I didn't even know until I started researching this talk. Apparently, you can just do set, like syscall, like the Linux stuff that I just talked about with the whole rerouting syscall. Apparently, you can do that on Windows, too. You can just go, I want to hook this. And it goes, OK. Had no idea. Set thread context is a little more exotic, but it's kind of fun. It's a little older. It was more popular in like the 98 days because you didn't have some of the, well, let's just say the stack changed. So set thread context is where you walk into a process and you suspend all the threads. So everything is paused. And then you add a thread, and then you change the context of the program to include all the functions except yours. And what happens is then you resume all those threads. And when you resume the threads, anything that doesn't have a fancy flag in memory that says this is part of the actual program and not a shared object, Windows basically assumes as a shared object, and now you're in shared object space. DLL redirection, it can be done in memory. You can find a pointer to a shared object and just move it and say point to mine instead. On modern implementations, they're getting very, very good about cracking down on that because it's easy to see and because it was used a lot. And yeah, it still works, but it's dangerous. But it can also be done on disk, where you can, this got really popular after a while. You can, there was a standard, I think there's a patch for it now in Windows, but there was a standard implementation flaw where you could take a DLL and stick it in the same folder with a program. And if it was the same name as something that it thought it was supposed to load, unless that program was patched against it, it would just load it in memory. So it's kind of cool. LD preload is a trick on Linux where you can say before you load this library, load my library instead, or before you load this function, call this function, so you can man-in-the-middle functions. It's really good for debug, actually, but it obviously can be used for surveillance. It's also really good for cheating on games. And then DLD insert libraries is the same thing as, it's just on OS X, and that's how OS X does it. There are some slightly different rules about things you can do on DLD, but Apple has different rules about everything because Cocoa, and Cocoa is a horrible invention. Process migration is probably the most aggressive form of in-memory persistence. You basically just pause the process, you dip into the assembly of the program, and you put your own shit in there. You just move everything around, and hopefully you do that without breaking the program. And there's a bunch of ways to do that, and probably the most elegant solutions do that, but you have to get everything right, because otherwise, obviously, you're probably going to get a super hard system crash, and the user is going to notice and be like, what the fuck? Or there's really derpy ways to do stuff. You can just modify a library or modify an application and /kill, then start it again. This works really well on web servers because sometimes web servers go down and the DevOps standard philosophy of oh my God, my web server keeps crashing, is put a load balancer in front of it. Which is great, because that means if there's 20 web servers and I hack one of them, and one of them goes down for 10 seconds and then comes back up, they usually go, don't care. You can do the same thing with libraries and their shared objects. So on-memory persistence, which usually for true persistence you're going to have to do at some point. Obviously there's a trade-off here between staying stealthy and maintaining access. So all of the ways that don't require getting into the system internals of whatever your target is, where you're just going to modify a binary or modify a library, I highly recommend just going and reading this source code. Josh Pitts is an amazingly smart individual. We've worked together on a couple of other projects, and this is kind of his pet project. He is the, HD Moore is to Metasploit as he is to this, and it supports, some 25 odd binary types, and it's very straightforward. You write shellcode, and you go backdoor factory some shellcode, this DLL, and it goes okay, and it goes through the DLL or the exe or the whatever, and it looks for things that are called code caves. Code caves are anywhere in the program where there's a jump to somewhere, and then at some point it will jump back, hypothetically. And what it does is it says, oh, that jump to somewhere is a code cave. So it modifies the program where it takes your code, sticks it at the bottom, and goes, jump to me. Now jump back. Done. And it works on everything. It's super fast. And now it has proxy mode, so you can run it as a web server, and you can just farm executables through it, and it will backdoor them as they come down. You can run it as a service, which is really fun, because you can do things like run a BetterCap or run a SSL man in the middle proxies, and anytime anybody gets an update that's not signed, it'll inject on there. It also has a bunch of stuff on the Windows side for auto-reading DEP protected systems, so you can tell it, here's a folder full of DLLs, find me one that's not dept and inject into there. And then I'll go, all right, let me take care of that. There's also a lot of more visible ways that you can do stuff. You can install a Windows service, which I don't know why every AV in the world doesn't catch installed services. I mean, most of them do if you're really stupid about it and you're using a garden variety, either black hat payload you've picked up off the Onion, or you're using Metasploit. But honestly, you tweak a binary just a little bit, you install a Windows service from a command shell, and it doesn't even blip. I don't know why that still works, but it totally does. Cron, obviously, I hope most of you know what cron is. It's the clock in Linux. You can add a cron job. Launch HD is basically cron on OS X. It's cool. And then I already talked about DLL redirection and how it can be done on disk. It can also be done in memory. It can also be done by patching registry values to point to different DLLs. There's all kinds of capabilities. You can also be really lame. And this is pretty much the way every pen tester gets into every system right now in the white hat, gray hat context. This should not work. This is go look in this folder. Oh, gee, leak.exe is there. Why is it there? Turns out nobody looks. This stuff totally works. You can just go into all user startup. You can add things. You can go. So the reason there's two different options there on the slide is because the top one will work anytime. I'm trying to remember. One works anytime that the computer boots up, and another one always runs a system, and the other one runs anytime the person logs into the computer. I forget which is which, but same job. You can add a line to the bash RC or the bash profile or the Z shell RC, or you can modify bash itself, tons of stuff like that. initd is a fun one because it's, if you get root, it's easy enough to mess with, and most stuff isn't tripwiring it, but it's also static enough that most people are not manually going in and changing their initd scripts unless they're messing with a server, and if they are, they're messing with that one because usually they're afraid to break everything else. Doing a USB autorun and and back in the day, CD-ROM autorun scripts is actually really effective for context. If you want to write payloads that will Stuxnet style breach air gaps, you can just say anytime there's a USB, run this payload, and this payload will write a thing to some block. Done. Also, network connections. This is kind of fun. So The enterprise one that most people will be familiar with is on Windows. There's this thing, there's the domain, and the domain has a GPO file, and you can basically modify the domain to be that any time that anybody logs in and they get the domain file, say run my payload. But you can also do all kinds of other context switching on other operating systems. Little Snitch, for example, is a pretty well-known network monitor, and it's a really awesome tool. I mean, I use it. It looks at all the traffic going in and out of your computer, and it lets you build completely customizable profiles, as well as some base user interactions for any time that it detects certain types of traffic. Anytime, and you can get down to like the packet layer, where anytime you see a traffic that looks like this, or anytime that you see this process send more than this many packets within this amount of time, and you can get really detailed and lock down your machine with it, which is awesome. It also means you can add a rule that says, anytime you see this traffic, run this ODay. Beyond that, there's a bunch of super exotic ways that you can stay persistent in memory, and they're mostly used by feds. Because they're really labor intensive to find without talking about them on the internet and blowing them. They're even more labor intensive to develop because they usually involve some level of hardware testing, and hardware's hard. And then beyond that, they're usually just incredibly specific, right? I mean, if you get a bug on a BIOS that lets you write code on it, it's only going to work on that version of BIOS. Even if there's several thousand of them in the world, how do you know that your target is going to have that BIOS before you pop your target? There's some vulnerabilities out there for hiding in GPU memory. This is kind of nice for persistence because it's not typically checked, and it doesn't involve technically a disk write. It also typically has DMA access, so that's kind of cool. If you know that your target is going to use things that engage the PCI bus a lot, you can have a GPU process that just writes back to itself. It's typically quiet, but again, incredibly targeted because there's lots of different GPUs out there. There's been a lot of stories recently in the news, well, not recently, but in general in the past few years in the news about some major nation-level actors hiding stuff in the microcontrollers on the hard drives, because the way that hard drives have to work, they're basically blank slates, and the microcontroller is the only thing that actually knows where the bits and bytes are on the platter or the chip or whatever. So you can hide logic in there. There have been some vulnerabilities released for CPUs directly. A particularly cool one that came out probably within the past 10 years is Joanna, what's her last name? Yeah, what he said. I don't know. I'm not Russian, I can't say that shit. She had a bug that she dropped at, I think it was Kansas West first, where the L2, the layer 2 cache of a particular type of Xeon processor had a flaw, and she figured out how to exploit the firmware on the x86 chip and then write permanent code to the L2 cache. So the malware was in the CPU. So you could rip out the hard drive, rip out the video card, take all the peripherals off, and even swap the motherboard out and take that chip and put it back in another thing, and your malware's still there. So it's pretty rad. Funny story, there's actually a company based on that exploit. They wrote a hypervisor verifier, and they install it to the chip using the exploit. It's kind of fun. The master boot record, it's very visible. Every AV tends to check it, but if you can get root enough to the system that you're doing exploits like these, that's probably the most accessible thing to like us regular humans on this slide, because it's pretty easy to just turn AV off and then write to the MBR. A lot of times there's hashing involved in that, but now with some of the UEFI bugs that are coming out and the way that the UEFI interacts with the master boot record, it's actually getting easier to do that because it's getting harder to hash them. I've used some MBR stuff in the past, and it tends to be relatively easy to massage in order to get access. So once you're in and you have all these listeners in place, you need to get data, right? So, data mining. The best way to data mine a client first is the browser, because humans pretty much live in their browsers. With your browser, I basically have a seismograph for your life. I know when you eat. I probably know what you eat because you look it up on new places. Where are you going? Are you going to Yelp? Are you going to Facebook and talking about it to friends? I know who you eat with. I know when you sleep because the activity is low. I know what porn you like. I know when you watch your porn. I know how long you watch each video. I know what news you read. I can change the news you read. So if I want to start doing psychological things, or I want you to be very depressed for a certain amount of time because it makes you unable to do a certain task, if I want to keep you up all night, right, I can steal your Facebook password and then pretend to be your friend and tell you I'm really thinking about committing suicide, and I can have a 2-hour conversation with you, which makes you tired at work, which is a real good time for me to launch whatever bug I want if you're an admin. Like all the really horrible, dastardly, movie-level, insanity-level human intelligence shit that you see people do or that we hear about people doing in meat space is all, the browser is the way to do it to people over the internet. Anything I can see, I can replace, and I can influence what you consume. Obviously, the logical escalation from the browser is social media, right? Social media is the key to everything. I can honeypot you. I can change your travel dates, make you miss flights, add flights that aren't there. I can take banking information and make purchases or donations to organizations known by third-party governments as supporting terror, and then I can leverage that as extortion and say, do what I want, or I will report you to the FBI or Mossad. I can, Anonymous has been known for using it to put child porn on recordable accounts, and then, ransoming people. It's the logical conclusion and escalation of everything we talked about with browser stuff. Video and cameras. So video and cameras are nice. One notable thing you can use them for is making false IDs as other people. This works really well for me on clients when I need to make a badge, because I can pop a laptop and then take a cam shot when they're not looking, and even if they kind of think it's weird because the light turned on, they only get it once, and now I've got a badge as that person with their picture on it, and I can tweak it. It works pretty well. But usually I find that audio is way more important than video. Being able to listen to conversations for long periods of time, and mining those conversations for information and being able to make links, hearing people talk about the data that you're downloading will answer all kinds of questions. Oh, I popped this wiki and it's internal to this organization and they're a bunch of activists, so they keep it on Tor, and they have these policies and procedures on how they talk to each other, but how do I know if they really follow these procedures or if they're just kind of lazy about it and this is the way they documented it? Well, if I hot mic somebody's phone and I hear them talking about that wiki, now I know, oh yeah, they actually do this part, they don't really do that part, etc. I didn't actually finish this slide. It was supposed to be a slide about metadata. I don't really think I need to go into it. I mean, there's enough stuff in the media. I think we all know how GPS locations and when you say whatever you say can be correlated into scary. And obviously, more access, right? SSH keys, VPN keys, SSL keys. I can keylog stuff. My favorite way to keylog is I love that everybody loves password managers now, because the internet just figured out that having shitty passwords is shitty, and all of them have password managers now. Password managers that are encrypted are great. Yeah, you know what password managers are? They're programs. You know what I just spent 30 slides explaining? How to backdoor programs. my favorite is, so I put this program and it's a keylogger and it only runs for 10 seconds. And I stuck it in your LastPass, and then I waited for you to log into, anything. And you type in the password to your LastPass, and then I download the LastPass database. Sweet, now I have everything. It's all in one place. So getting the data, great. Now we have a whole bunch of data, volumes and volumes of data. Processing it is no easy task, because we are not armies of PhDs, and if we had them, that is a difficult problem. That's a problem so difficult that that's what most of our governments are spending all their money right now. There's a quote from Robin Williams from one of his stand-ups where he's pretending to be different nationalities and telling all these jokes. And so at one point he's telling jokes about Russians and being in the Russian government, and he's talking about nuclear bombs. He goes, "Russia, we have many bombs. We don't know where they all are, but we have many of them." Right? Well, replace bombs with data and you basically have every modern intelligence agency. Oh my God, they're building these giant hard drives. No, those are giant processors. They've had hard drives for years. They have all this data. Sifting it is fucking hard. So I've actually had to kind of delve into this space because I've been on some engagements recently where I've had this problem where it's oh man, I have all this data And I know that, there's stuff that I want in there, and I don't really know where it is. And there's terabytes of it. It's all different file formats. Some of it's Word documents, some of it's old Word documents, so I can't just unzip them and browse them as XML, because that's what the new Word documents are. Videos, pictures, password data, random text files written by humans that make no sense. It's very difficult to automate. One of the ways I've had some luck is there's a search program by Apache called Solr. And it's very, very, very well documented. It's a massive project. It was, it became the de facto open source solution to building your own search engine. But you can run it on local data sets. It can be kind of a pain in the ass to set up, but once you set it up, there are some great parsers for it. One of them is, I think, Lucinaire, or Lucine, I think is how you pronounce it. And yeah, there's some tiny little front ends. One of them, I can't remember the name of it, but it's entirely in HTML5. And you can just set up a NAS or a Drobo and throw a whole bunch of data in there and then index it with Solr, and then you've got a search window. You can just type passwords, or if you get a name out of there, you can type Jeremy, and a bunch of data comes up. It's kind of useful. If you are not doing things you're worried about large organizations hearing, if you're not worried about crime and you're on an engagement or something like that, Slack is actually really awesome for a logging tool. So I recently did an engagement where I was sitting with 3 people, and we were popping a relatively large organization, and this is our chat. And it was awesome because anytime we'd get anything, I could just drag and drop my file into Slack, and I would have a time index of when I had it. I'd have a comment field to talk about how I got it. I'd have reference to conversation in and around the object. And I'd get metadata around the object in terms of size and type. And then later on, when the engagement was over and I wanted to put these things in the report, I've got search throughout the entire Slack channel. So I can go search for stuff and get the conversation around the object and the actual file, all in time delineated orbit. And then when I'm done, I just nuke the channel. It's actually pretty useful. Also, there's an API for Slack. So one of the things I don't know if I'm going to show that part yet, because there's a thing in it. I don't know if I'm going to show that part yet. But the implant I'm going to show you after we turn the cameras off, when I show you the catcher, which is just a HTTP server, just keep this in mind for later. I also made it talk back to Slack. Super useful. talking, and then a bunch of shells call back. Hey, let's play with the shells. An alternative to Solr is Orange. Orange is basically just a local open source, or actually I don't know if they're open source. I think they're not open source. Anyway, they're freely available. Project to basically do the same thing. A bunch of file parsers, goes through them, adds an indexable format. If you have all the money in the world, Tableau is pretty much like Silicon Valley's solution to data indexing these days. That obviously requires much more tooling because everything is going down to one browsable data format, which is CSV. But that's kind of the point, right? Once you have universal indexing, then you have universal searching and access and context, and you can apply all the data science you want. And if you really just don't care about anybody else reading your data, or if you figure out how to anonymize it without getting caught, yeah. I can see all the academics giggling in the room. Or, of course, good old-fashioned regular Linux tools. It's really sad how many calls I get in the middle of the day from pretty accomplished testers who are like, hey, I got this password dump, but it's in this format, and I can't get it into John. I'm like, learn to grep. Can you do it for me? All right, fine. Learn your basics. So we'll get to the demo, and I'm certainly going to take questions before we do that, so that way those get recorded and so that the streamers have access to it. But basically, in conclusion, your targets are humans. So don't study machines entirely, study humans. Those are your targets. Don't reinvent the wheel, because tools exist out there. Figure out how to leverage them, because you will save time. Practice, practice, practice. Dev is not easy for a reason. And when you're deving for Black Hat tools, you're basically doing 2 jobs, so you should prepare for it. And if possible, in whatever your endeavor is, if you can involve either multiple endpoints or more specifically multiple people, more brains are better than one. So multiplayer when you can. Questions? Not even done yet. That's the question. No questions? Oh, you all want to see the shell, that's what it is.
All right, turn the cameras off. I'll show you the show.